All right, everybody, what is going on? This is for the weather review questions that I'm posting up. All right, let's get started with number one. So, number one says the diagram below shows a weather instrument used to determine relative humidity. All right. And so, what we have here is this weather instrument that we know as a psychrometer, right? Something that measures the dry bulb and the wet bulb. So, question, sorry, what is the relative humidity? So when I'm looking at the dry bulb, I see right here, it looks to be 22 degrees Celsius, right? So my dry bulb, I'll put right here, put it on the side, 22 degrees Celsius. And what is my wet bulb? It looks to be about 14 degrees Celsius. All right. Now, when I look at my chart, there's two things that I need to know. There's two things that I need to know. Sorry. All right, sorry. So when I look at my chart, page 12, and I'm looking at relative humidity, what I need to know first and foremost is the dry bulb temperature, right? And I also need to know the difference between the wet and dry bulb temperature. Well, my dry bulb temperature was 22 degrees Celsius. My wet bulb temperature was 14 degrees Celsius. To use this part of the chart, I need to know the difference between the wet bulb and dry bulb. And when I take a look, the difference, right, 22 minus 14 gives me a difference of 8 degrees Celsius. So that means I'm looking at 8 degrees Celsius as the difference between the wet and dry bulb, and 22 degrees as for my dry bulb temperature. And when I match them up, I get 40. 40, and what is it? 40%. Because if we take a look here, we see that the relative humidity is measured in percent. So that means that my correct answer is choice, oops, here we go, is choice A, 40%. All right, number two. So we're taking number two. It says, what is the dew point when the dry bulb temperature is 20 degrees Celsius and the relative humidity is 17%? So it says, what is the dew point? So when I'm looking, I know that in order for me to find my final answer has to be in one of these numbers, right? All of these numbers represent a dew point temperature. And when I go back to my question, one of the things I already know to use on the chart, they says, what is the dew point when the dry bulb temperature is 20 degrees Celsius, right? So let's stop here. The dry bulb temperature is 20 degrees Celsius. So when I take a look, I know that my one of my parts of my answer is going to be right here for the dry bulb to be 20 degrees. So that means my answer is going to be one of these numbers here. Now, they don't tell me the wet bulb temperature, but I need to somehow find a way to find the difference between the wet and dry bulb. What else do they give me? Well, when I look at the problem, they're also giving me that the relative humidity is 17%. So that means I'm going to have to use my relative humidity chart to find the difference between the wet and dry bulb. So when I take a look, right, my dry bulb in the problem was 20 and my relative humidity was 17%. So I'm going to follow here until I find 17%. And by knowing the dry bulb and the relative humidity, I'm able to find the difference between the wet and dry bulb, which is 11 degrees Celsius. Why is it important that I found this number? Because now that I found that my difference is 11, now when I move to my dew point chart, right? When I move to my dew point chart, take a look. My difference now was 11, and my dry bulb is, my dry bulb was 20 degrees. Now that I switch to the dew point chart now, dry bulb is 20, difference is 11, and my dew point ends up being -5 degrees Celsius. Why? Because remember, dew point for this chart right here is measured in degrees Celsius, which would end up being choice number 1A. All right, number 3. Number 3 says the map of North America below shows the source regions of an air mass forming mostly over Mexico. This air mass originating over Mexico is classified as blank. So all of these names that we see here are the names of different air masses. And the first thing that I just know is the names of these air masses are also located on page 13 of the reference tables right here. All right. Now, what else do I know about this problem to help me? So this source region, was it created on land? Yes, it was created on land, right? This air mass was created on land, not on water. So we know it's created on land. And what else do I know? I know that the temperature of this source region for the air mass is going to be warm. How do I know that? Because Mexico is not too far from the equator. And so Mexico is generally a warm place. So this air mass has to be warm, and we know that it had to be created on land. Because it was created on land, I know that it has to be a continental air mass, right? It has to be a continental air mass because creating on land means it has to be continental. And because it was warm, it has to be tropical air mass, which makes it choice B. Continental tropical, right? It was created on land, means it's continental, and it was created in a warm area, which means it's tropical, CT. All right, number 4. Number 4 says the weather map shows a storm center north of Iceland, and it points A, B, C, and D indicates locations on Earth's surface. Isobars are labeled in millibars. So all these lines are measuring air pressure. Keep that in mind. It's measuring air pressure, atmospheric pressure. It says which location probably experienced the highest wind speed. It has to be a location where the isobars are closest together. Where the isobars, right, these lines are closest together. All right. When you have the isobars that are closest together at a location, you're going to experience the strongest winds, which is location A. All right. This rule remains true when we are dealing with isobars, a map that has isobars labeled. All right. So the correct answer is choice A. All right, number 5. Number 5 says the map below shows a position of a polar jet stream north over North America in January. Which map best shows the air mass movements associated with this jet stream position? So something to keep in mind with jet streams, right? We consider them to pretty much be strong winds. And these winds have the ability to carry weather systems, right? These strong winds, the jet stream have the ability to carry and transport weather systems. All right. So when I'm looking at this question, I'm actually looking at this question as a which diagram represents to be true? Which diagram is represented to be true? All right. So when I'm looking, I know, for example, an air mass could not have been originated here because MP air mass represents wet and cold. And so because of the fact that this air mass is created at a region that is not too far from the equator, that's why it can't be B. All right. When I'm looking at C, right, once again, I see MP air mass. Last time I checked, MP air mass is a wet and cold air mass. Aren't wet and cold air masses, isn't a wet air mass created in water, right? Not on land. So that can't be true. And continental air masses, aren't they supposed to be created on land, not on water? So that can't be true. And the same thing that I see here, MT air mass, right? Which means warm and wet. Warm and wet air masses did not originate in the northern part of Canada, right? It is cold up here. It is not warm over here. And a CP air mass, right? Which is a cold and dry air mass. How can a cold and dry air mass be created at a location where it is warm and wet? So it can't be that. That's why the correct answer is A, right? Warm and wet air mass was created right here. It makes sense. It was created in the water and it was created in a warm location, traveling upwards because of the jet stream. And we have a CP air mass, right? Cold and dry, which makes sense because this air mass was originated on land, which represents as dry, and it was originated in the northern part of Canada where it is cold. So A is the correct answer. It holds itself to be true. All right, number 6, it says, compared to the temperature and relative humidity of the air at point A, describe how the temperature and relative humidity of the air are different as the air arrives at point B. As the air arrives at point B. So when I'm looking at a comparison question, I'm always looking to make sure that I'm looking at the last part of the question. Why am I looking at the last part of the question? Because I know that I'm going to describe temperature and relative humidity at point B, right? At point B. So here is where I have to describe the temperature and humidity at point B compared to A. So what do I know about A? On the windward side, where clouds are being created, I know that the temperature is cooler and wetter on this side, right? Where clouds are being formed. On the leeward side, where air is sinking, I know that the weather condition is warmer, right? Because air is sinking, and drier. All right, because air is sinking. So, and as we can see, there are no clouds on the leeward side, right? And so therefore, my answer is going to be that the temperature and relative humidity are warmer and drier on the leeward side of the mountain. This is just something that you do have to memorize and remember. When air rises, right? Air rises, expands, it cools down to the dew point and condensation occurs. To reduce clouds, we have air that is sinking, right? The air is compressing, it's heating up. That leads to evaporation, and you have evaporation at a high rate in dry conditions. Number 7 says, based your answers to the following question on the map below, which shows the position of the jet stream relative to two air masses and a low pressure center over the United States. What is the difference in the air temperature and humidity between the CP and the MT air masses? So we do just have to remember, right? If you ever forget what the names are, right? CP and MT, they're located on page 13 of the reference tables. All right, so CP represents continental polar, MT represents maritime tropical, right? We know the word polar, right, associates with being cold. Continental means that was created on land, which means that it's dry. Sorry, I messed up on spelling. Forgive me. right? We know that it's a cold and dry air mass. And we know what maritime tropical associates with warm air, and maritime associates with wet, or you can say humid air. All right. So now that I know the difference, CP represents cold and dry air mass, MT represents warm and wet. When I go back to my problem, what is the difference in air temperature and humidity between the CP and MT air masses? With the only best answer is going to be choice 3, right? Because it becomes a true and false. As I just mentioned, the empty air mass is a warm and wet air mass. So this statement is true, right? It's not going to be D because empty air mass is warm. And it's not going to be B because a CP air mass is dry, right? So that means it's not more humid, it's less humid. And it can't be A because a CP air mass is cold and not warm. All right, number 8. It says, base your answer to the following question on the weather station model shown below. And it says, state the relative humidity. When I'm given a weather station model, right, there are 2 numbers that's going to help me to determine the relative humidity. And what are these 2 numbers? Is going to be, right here. It's going to be the temperature and the dew point. These are the 2 characteristics that I need to determine the relative humidity, temperature and dew point. And I know, right, which is the top left number and the top right number. I know that the closer the air temperature is, which is the top left number, right, and the dew point, which is the bottom left number, all right, the closer these temperatures are to each other, the more humid a location is. What happens when it is equal to each other, the temp and the dew point? Well, when the temperature and the dew point are equal to each other, there's only one thing that we can see, and I'll prove it on the reference tables, all right? If we go to page 12, all right? If you see here, when the dry bulb temperature and the dew point temperature are equal to each other, right? When the dry bulb and the dew point temperature are equal to each other, the difference between the wet and dry bulb is always 0, right? Dry bulb is 2, dew point is 2, difference is always 0. Look what happens to your relative humidity when the difference between the wet and dry bulb is always 0. 100% of the time, your relative humidity is going to be 100%. So that just lets us know when the when the air temperature and the dew point temperature are equal to each other, the relative humidity is going to be 100%. The air is saturated. All right, number 9. Number 9 says the diagram below represents a cross-section of air masses and frontal surfaces along line AB. The dashed lines represent precipitation. All right, so it says which weather map best represents this frontal system? Well, what do I know? I know, let me see this right here. I know that when a cold air mass is forcibly pushing warm air to rise directly upwards, I know that this scenario right here is a cold front. All right. And what do I also know is when you have warm air mass that is creeping over hovering and creeping over and rising over cold air mass, right? In an example like this, I know this is a diagram of a warm front. So what do I know as I head from A to B? As I head from A to B, I'm going to experience a cold front first and a warm front first. And the cold front, right, the direction the cold front is moving is the direction where the cold air mass is moving, which is to the right. And the direction the warm air is moving is the direction of a warm front, which is also moving to the right. So I need to pick a diagram where I experience a cold front and a warm front, and they both have to be moving to the right. So which one shows that? Which one shows a cold front first and then a warm front, and they're both moving to the right? The one that shows that is choice C, right? I see the cold front moving first, and then the warm front that is next, as I just described it. And if you ever forget these symbols, the representation of these symbols, you can always go to page 13 of the reference tables. And right here, it lets you know the symbols of a cold front and a warm front. Page 13. All right, number 10. Number 10 says, base the answers to the following question on the weather map below. Points A, B, C, and D are locations on Earth's surface. Which type of front extends southward from the center of the low, right? So the low is right here. How do I know that? Because it literally says low, right? The low pressure system. And it says which type of front extends south from the center of the low. So I'm looking at the front that is south of the low pressure system right here, right? And what do I see? I see that this front system is all triangles. When I look at my reference tables, which front symbol is all triangles? And it is the cold front right here. You see it's all triangles? So that's why the correct answer is going to be choice D. Number 11, which station model represents the location that has the greatest chance of precipitation, right? So precipitation is, we can describe it as whatever is coming out of clouds, right? Whether it be rain, whether it be hail, whether it be snow, right? All of these things are different examples of precipitation. So I know the greatest chance that I'm going to have for precipitation, number one, is that it has to be cloudy, right? It has to be cloudy. If I want the greatest chance of precipitation, it has to be 100% cloudy. It has to be 100% cloudy. That's number one. So that's why it can't be C or D. The other thing is, the closer the air temperature is to the dew point, the greater the chance of precipitation. And so when I'm looking, my air temperature is the number on the left, top left, and my dew point is the number on the bottom right. And if you notice, the numbers, the difference between the air temperature and dew point at A is 7 apart. However, the difference between B is only 1 apart, right? 81 to 82 is much closer than 23 to 30. That's why the correct answer is choice B, because it's 100% cloudy, and the fact that the air temperature is very close to the dew point temperature number. All right, just keep in mind the dew point can never be higher than the air temperature. All right. All right, number 12. Number 12 says, base your answers to question 12 and 13 on the map below and on your knowledge of Earth science. The map shows typical weather systems over North America. Letters X, Y, and Z represents locations on the map. The isobars on the map are measured in millibars. And so it says, which type of front extends northwest from location Y? All right, so what type of front extends northwest? Remember, northwest from Y is this direction, right? Northwest is from that direction, right? If this is north, east, south, west, northwest direction is between north and west. All right. So with that being said, that means I'm focusing on this front right here. I see a circle on one side, triangle on the opposite side. Circle on one side, triangle on the opposite side. Which front symbol matches that? Well, I'm going to go to page 13. And what do I see? I see circle on one side, triangle on the opposite side. Circle on one side, triangle on the opposite side. This is clearly a stationary front. All right, this is clearly a stationary front. And so therefore the correct answer is going to be choice D. All right, 13. Which map best shows the locations for the center of high pressure and low pressure? All right. So which map shows the location for the center of high pressure and low pressure? Okay. So I know that all of these numbers here, they represent millibars. Millibars, right? All of these numbers here, they represent air pressure. All right. High pressure means that the pressure at that point of the H has to be at the highest value, the highest pressure. L symbol represent that the pressure has to be at the lowest value, right? So which map am I seeing where H's are at the highest pressure and L's are at the lowest pressure values? Well, I'm taking a look, right? Right here, this doesn't make sense for D because L is at the center of 1028. That doesn't make sense. When I'm looking at C, I see H right here, right at the lowest value of 1008. So it can't be that. When I'm looking at B, I see your L and H, they're not even focusing on the highest or lowest points. They're focusing in between, right? In between two numbers. So it can't be that. That's why the correct answer is A. That's why the correct answer is A. All right, the correct answer is A. And as we can see, it makes sense, right? The high symbols are located on the highest value here. The L symbols are located on the map where the lowest air pressure, the center of the lowest air pressure here. All right, that's why it is choice A. All right, everybody, let's go to question number 14. So base your answers to following questions on the weather map below, which shows the locations of fronts and the temperature field on a given day in the United States. So it says the passage of a cold front most recently influenced the weather of which two cities, all right? So when we're looking for a cold front, I need to know the symbols, all right? What page am I going to look at, everybody? I'm looking at page 13 of the reference tables. So cold fronts are the symbols that have the triangles, okay? So now one thing that I know is that cold fronts are actually moving throughout the country. They want to know which cities did a cold front just pass. So I'm going to be looking at the cities. I'm going to be looking at the cities where a cold front just passed not too long ago. So I see Minneapolis, all right? I see Minneapolis. I see possibly Fargo. I see Kansas City, Oklahoma City, all right? I even see San Francisco, all right? These are all the cities that's literally right behind a cold front. So which option out of these 5 cities, which option shows where it's consistent of 2 of these cities that just passed the cold front? And so the correct answer is choice C. The correct answer is choice C. All right, everybody. So we're going to go to question number 15. The atmospheric conditions at a given location are represented by the weather station model below. And it says on the lines provided below, fill in the correct information for each variable listed based on this weather station model. All right. So let's start off with the first one, air pressure. When I look on page 13 of the reference tables, the air pressure is the number on the top right. Now keep in mind that there is a rule to take it out of the weather station model. All right. So let's take a look. At air pressure is 096, 096. And so therefore, when I take it out the weather station model, it is less than 500. So what do? I add a 10 in front and a decimal between the last two numbers. All right. And so that's why it's 1009.6. All right. Now, air temperature is located where? Air temperature is the number that is located on the top left. Is located on the top left right here. So therefore, my temperature number is going to be 46. Amount of precipitation during the last 6 hours is this number right here, which would be 0.15 inches. Cloud cover is how much it's shaded in, which is 75%. And the present weather, right, which is this dot, when I look at the reference tables, I see that the dot means that it is rain. That it is rain. So when I go back, the present weather is, everybody, it is rain. All right, number 16, the diagram below shows weather instruments A and B. All right, so it says which table correctly indicates the name of this weather instrument and the weather variable that it measures. All right, so I know for a fact this kind of looks like almost like a stopwatch. That is called a barometer, right? And that measures air pressure. Okay. And this device right here, especially we see like these cup looking things, right? This is a anemometer. Oops. Yes, anemometer. Oops. Sorry, guys. Gotta spell. All right. And that measures wind speed. So which option shows the correct choice between A, B, C, and D? The correct answer is choice D. All right, everybody, we're looking at number 17. So number 17 says, on the weather map station model above, using the proper format, record the 6 weather conditions shown below. All right, and I know how much we love weather station models, so we are ready to cook. All right, so first and foremost, we got the wind from the northwest. Wind from the northwest means that I'm going to draw my line, my long line, northwest. All right, that's the first step. Then it says wind speed of 10 knots. That's just one long feather, 10 knots. Now it says barometric pressure of 1022 millibars. Remember, when you're converting it back into the weather station model, you remove the 10 or not in front and the decimal. And what's left is 220. 220. Cloud cover is 50%. Cloud cover is 50%. So therefore, it's going to be 50% shaded in. It's going to be 50% shaded in. Visibility is 5 miles, which means that the number is going to be 5 to the left. And precipitation in the past 6 hours is 0.45 inches, so I'm going to write 0.45. This is how your weather station model should look. All right, number 18, it says, base your answers to the following questions on the cross section below and on your knowledge of earth science. The arrows on the cross section represents the air movement along a weather front between two different air masses. The air masses are labeled, okay? Automatically, I see a CP air mass definitely represents what? Cold and dry air mass, all right? And an empty air mass represents warm and wet air mass, all right? And it says clouds are forming along the front because rising air is what? All right. So first of all, we know, isn't this a diagram of a cold front? I just want to mention that, even though it doesn't say on the problem, this is a diagram of a cold front. And we know that clouds form because rising air is doing what we know as REC, right? What is the acronym for REC? We know that air got to be rising. Let me just write that down real quick. Let me change that color. All right, bada bing, bada boom. We got REC, right? And what do we know about air? Air has to be rising, then expanding, then cooling. The temperature needs to, the air pocket needs to cool to the point that reaches dew point, and then condensation occurs. All right. And so which option shows that rising air expands, cools, and then causing condensation? It is what, everybody? It is choice D. All right. Thank you so much. All right, for this time. If you got any questions, please just let me know. All right. Make sure to like and subscribe, and make sure to have a wonderful, blessed day. See y'all till next time.